love cooking for everybody else, but for me, not so much. So I'm using QL because it's healthy, it's micro elements, everything what it should be. So again, to not turn myself into barrel, I was using this QL, and I'm really not looking forward for my Huel dinner. So.
I call Huel misery dirt. I take it as well, and it's absolutely appalling, isn't it? It has no flavor.
Depends which one you're choosing. I love the coffee one. Oh my love! As a breakfast, I can't even imagine anything better than just maybe a good scrambled eggs with the toast and blah 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 blah. But for like a morning routine, the coffee Huel, which you have a real coffee inside, so it is because it's OAT, so it's releasing energy required for the long time after drinking it, and have a real coffee, so really kicks you for the morning. So whatever case may be, I told my friends and give them like a sample or something like that they tried. Nearly all of them stick for the breakfast, especially the coffee Huel, because it's not only wakes you up, but also when you're on a hurry. When you don't want to cook like a big gigantic breakfast for yourself and family or something like that, the Huel in the morning, it is actually quite good. The rest, I don't know. It's just like I was trying to mix and match. So for morning it will be like a coffee. For late would be like a banana, but it still tastes extremely artificial. But for the dinner, I found it the mint chocolate. So it tastes nearly like an after 8. So it was really really fantastic. But okay, I am not endorsed it. I'm not sponsored.
I actually hear that some people take Huel and they make cakes from it. You can use it as like a base to do some sort of baking.
Yeah, so some time ago they even have a website, a blog, where they shows up what you can do, because in the end is a wheat with a little bit rice, beans and stuff like this. So literally this is flour, and it's just artificially where they put artificial micro elements and vitamins and stuff like that. So I always ask myself how they adding the iron. So it's just like I imagine like a guy with a nail just scrubbing on top of a tank with this. Because how you add the iron, what is necessary from the back of the flour, basically.
Mm-hmm.
Huel is actually disgusting. I did a taste test of a few different types of these, like powdered whatever replacement drinks, and okay, I only tried the vanilla Huel, but
poor thing. So if someone will, I know what you mean, and when I started, it was only this original one, and I think there was chocolate one when I started trying this, and I ordered it was original and unflavored. Unflavored straight away go to the bin, because I could not do anything with that. But with the vanilla, I find out that if I make an espresso and added to it, just the bitterness of the coffee was killing this artificial vanilla flavor, and make it like a vanilla mocha. Of course, if you close the eyes and drink fast. But then they released the real coffee one, and this is something what you really can do without manipulating this left and right. Sometimes my friends, they took and add like a full banana into vanilla one, so this makes it drinkable again. But this is the thing what I do not like about this basic ones, because you have to do something with them. But with the coffee one, on the beginning it's just like tastes like someone would pull coffee into like a odd portage. But if you get used to it after 5 minutes, it's totally fine. Again,
I commend you. I think everybody's been making sourdough, so I think it's nice and refreshing to hear of somebody having something else.
Well, yeah. I mean, so I'm kind of like, I've gotten to the point where I'm trying to stay away from bread, because that stuff I just gain weight whenever I eat it. So I've I've kind of switched to like more of a ketogenic type diet, but not full on like crazy, I'm going to have 0 carbs. But one of the things that's helped a lot, and I don't think they have it in the UK, is something called Ample K, or Ample Foods. It's AMPLE. And it's actually really good. Like the combination they made is like a vanilla cinnamon, and you can drink it alone. And it's amazing. I've tried Soylent, I've tried Huel. I can agree with you, it's disgusting. But the Ample ones are really good. I don't think you can get it over there though. I always bring it with me whenever I travel. And but yeah, the pre-made meal stuff, like the meal replacement stuff, is like pretty great because it's portion control and it has all this great stuff about it, but most of them I've found are like pretty gross. They're disgusting.
Don't blame it, man. In the end, it's just like, again, I don't like to cook for myself. And okay, maybe the different story is just like I find myself that I really like to make this very simple, like Italian pastas, like aglio olio, cacio e pepe, or whatever case may be. It's like 15 minutes and you have a lunch, but this is still a lot of carbs. So if
I have one more Huel story actually before we move on from Huel. My friend, she decided to get Huel and try drinking it. She also decided it was disgusting, but she thought maybe I can put an egg in it and make it as a pancake and then add like sugar to it and it will be okay. And she made it up as a pancake and she ate it. I was like, oh my God, it's still disgusting. And I wasted an egg. And this was like the height of lockdown when eggs were hard to find, right? So she was so sad because not only did she create something disgusting, but she had to use an egg, one of her precious eggs, for it.
I totally agree with that. Like, there's something incredibly bitter about when you invest a lot of time and energy into making food and it tastes gross, you know? Like when you follow a recipe and you get all excited about it. I once made this kind of beetroot pasta thing and I thought, this looks great. And I tasted it and I was like, this is one of the most disgusting things I've ever eaten. So I completely sympathize. It's like a special place in your heart where it's like, why?
I always think like a lot of cream, a lot of garlic, and you'll be able to save those recipes. And
you can't go wrong.
Go bad. Just cover the flavor of it.
Lots of salt. Yeah.
Yeah, or you can add all chili to make it spicy to the level that you will never taste anything else.
Pretty much.
This should be the cooking meetup. I think we got some great ideas here.
You know, everything what makes people happy. You know, it's just like we all have to eat, and you know, CNCF it's fantastic, and Kubernetes is awesome, but we all have to eat, and if we can eat it, you know, nice and healthy, and share the good recipes. Or something to do with the Huel.
So this evening, the F in CNCF stands for food.
Nice, I like that. I'm okay with that.
The Cloud Native Cooking Food.
Cloud Native Cooking Foundation.
I'll be okay with that. Combines two things that I really like.
I like the idea of the clickbait. You can have like 5 crazy things you can add to your Huel to make it taste good. Or
nothing, just throw it away. Okay, we've done enough advertising for Huel today, or maybe not advertising, the opposite. We are pretty much at 7 o'clock London time, so let us kick off. Oh, before I kick off, I'm sure you all noticed, but there was a registration code if you want 10% off KubeCon, so that's coming up. So welcome to Cloud Native London. We are a strong, open, diverse developer community around the Cloud Native platform usually in London. Of course, right now we are virtual and global. I'm Cheryl. I'm the VP of Ecosystem at CNCF, and you can find me on Twitter at OiCheryl. So I want to hear a little bit about you. So as usual, I'm going to ask you to go to this link, oicheryl.com/p, grab your phone, grab your laptop, whatever, and please follow along and sort of answer a couple of questions about yourself. if you're watching this on YouTube, then there is sort of a 5-second delay or so between Zoom and YouTube. So I'll take it slowly so that everyone on YouTube can catch up. And if you miss this link, oilcheryl.com/p, you can go to a longer one. All right, let's take a look. So is this your first time joining Cloud Native London? So you've got two options, yes and no. %, no. Problem with this tool is I don't know if this is one person voting or if this is like everybody's there. Oh, nice. I see, James, were you holding up your phone? You're voting?
Yeah, I'm the person, I think.
You're the one person?
Yeah.
Oh, no, okay. Hey,
no.
we got other people joining. Megan, I saw your voting as well. Here we go. Oh, so interesting. So a lot of, usually this is usually like 50-50 or maybe 1/3 new to 2/3 returning. So today looks like we've got a lot of returning people, which is awesome. Give it just another few seconds because this is still shifting.
I love how real time this is, Cheryl. This is awesome.
It's nice, right? This is a service called Poll Everywhere. So I really love it because you can actually kind of see it update in real time. It's got good integration with Google Slides. It's just a really nice tool.
It sort of reminds me of Mastermind, you know, ask the audience, 50-50.
Is Mastermind just a British thing?
I think they've franchised it.
Okay, because I know there's some other people on Zoom who are not, and on YouTube who I'm sure are not just British. So
I have no idea what you're talking about.
I guess if I was to quantify it, it's like a game show where you have the choice of asking the audience if they want to participate, and it's kind of a similar mechanism. They get a little controller.
Okay.
Okay, not an American thing. All right, let's keep going.
No, never heard of it.
I think people got the hang of this now, so let's move forwards, if I may. Ooh. All right, second question, where are you right now? So we've just got a map of the world because we're not just London anymore, but let's see where people are. Oh, I love this person. Is this Chile down here? That's awesome. Hello, if you're the person from Chile. Kevin, is this you in the US?
It is. That would be me.
Where in the US are you?
Smack in the middle of the US. In a little town outside of Nashville, Tennessee.
Very cool. Got someone from India. We've got, I can't see this one. Belgium, maybe? Testing my knowledge of world countries. Okay. But it seems like mostly UK people tonight. Obviously, I'm based in London, yeah.
Is that Saudi Arabia? No, that's not. That would be over there. Like there's somebody, I don't even know what country that is. It's right above where your mouse is, Cheryl.
I think this is probably northern India here.
Okay, India, yeah.
All right, let's keep going. Let's try and get to the next one. All right. What is your job title? Pick the closest if you don't have an exact, if your job title is not exactly listed. And if it's not, then put into the comments, what do you do? Just introduce yourself to people. Okay, definitely, architect and SRE/DevOps, and neck.
What's the profile you tend to get, Cheryl?
I'd say SRE and architect tend to be the top two. I think usually it's a little more SRE than architect, but it's pretty even. Tonight is definitely even. And if you are in other, as I said, please put what you do into chat and let us know. Okay. Feels like we slowed down. So yeah, SRE, yes, just edging ahead of architect. Okay, now we've got a couple of questions from the speakers, and these are things that Alex and Kevin and James would like to ask all of you. So here we go. What do you think is going to cause the next wave of innovation in cloud native technologies? So your options here are machine learning / AI, GitOps, edge computing, universal data plane, and other.
This is really interesting. I honestly thought GitOps would immediately get a lot of traction.
Kevin, James, what were you expecting from this?
I mean, I don't know. I guess maybe you can't say serverless is the next wave. That's kind of yesterday, right? So
it's not yesterday. I think there's still a lot of innovation in serverless.
Yeah. I mean, I'm doing my talk on serverless.
Yeah.
Edge computing basically is
this is really interesting, these results, and especially edge computing with things like K3s and KubeEdge. You've got a lot of cool projects coming up.
Yeah, there's a restaurant chain that's based in the US that is literally deploying K3s clusters in their restaurants on Intel NUCs. It's crazy. Like, so yeah, I think Edge is a pretty popular one.
Yeah, a universal data plane I put in there. It's a pretty interesting concept, but it's still only on a very, very small fringe of people looking into it. But it's the idea of linking together service meshes and distributed systems. So that could be kind of big in the future.
I saw someone in the Zoom chat said other COVID, which, not a bad answer. In fact, I think during COVID times, there's been quite a drive to push forwards with cloud native, to be honest.
Yeah, it's a great answer.
And Hubert, you said not a fan of GitOps. That's interesting.
I am not fan of GitOps on the maybe because I am using whatever meeting or talk I attend to, I do the cases what we're presenting not only do not fit to the company what I'm right now, but also from my perspective of how to design the workflow, especially with the bigger teams. It's just like, do not speak to me at all. But again, I am not a fan of the what is the name, Terraform, sorry, which for me, so I am just maybe I am unicorn, in my own environment.
It definitely seems like edge computing and machine learning are top two here in GitOps. If you said other, again, I'd love to hear what you think will drive the next innovations. Thank you for voting. Let's keep moving. Do you need to be a developer to understand JavaScript functions? So your options are you are a software developer and you know JavaScript, or you're not a software developer and you know JavaScript, or you don't.
Sorry, go ahead.
No, either. Go ahead, Kevin.
I was going to say, does anybody really know JavaScript though?
I was thinking the same thing.
Understanding of, recognize.
Yeah. Are we talking the JavaScript from the Mozilla and Oracle, or this one from the V8 Google?
I mean, JavaScript, you just go onto any random name generator, and then now you know the name of at least one framework, right?
Is it ECMAScript or is it JavaScript? I don't know. Talking about TypeScript, like I said, there's so much. The ecosystem around JavaScript is gigantic, and it's great because
absolutely.
You have a lot of freedom there to shoot yourself in the foot.
That's great, huh? It's like, I know enough JavaScript to know how dangerous it is. Oh, this is interesting. So it's exactly a third. Huh. Okay, cool. Oh, it looks like it's still slightly changing. I'm going to assume that was the last one or two answers there. And let us keep moving. So here is your last question. Which load balancer or yes, load balancers are you using in your environment? So your choices are Traefik, HA proxy, Nginx, Envoy proxy, something else in hardware, something else in software, or if you don't use any kind of load balancer at all.
But I can choose only one answer. It's not fair.
I wonder.
Choose the one you like the best.
I wonder out of those Nginx answers, if anybody's using Nginx Plus, or if those are all the open source offerings.
Yeah, it's a good point. I mean, there's a lot more traffic than I expected, to be honest. But there could be people here who are just here to see my talk because I work for them. Because if you look at some of the polls that Cloud Native Computing Foundation has done, it's usually traffic's around 12 to 15%. So it's pretty interesting.
I'm genuinely surprised that nobody's put Envoy, especially with the advent of Golang and the XDS within Envoy. It makes it very easy to program. But again, I guess is that knowledge and overhead in having to learn it.
Yeah, and I mean it's still relatively new too. I mean, it what came out this year, or was it last year?
Last year.
Yeah.
I would like to listen to a good talk about the edge computing, especially K3s. I think that this is will be the best way to find out if the traffic or HA proxy and Nginx. It's just like when you have a very limited tiny cluster, which one will really fit in the fastest way to fulfill your needs.
Yeah, absolutely.
Awesome.
I mean, you look at all the different proxies that are out there, and all of them have a lot of really great features, but a lot of times I think operators of the edge, they could probably use a more pared down, really lightweight proxy that is super fast, low overhead in terms of memory and CPU, and that's a good use case. And I'd be interested in seeing which proxy that's out there is more favorable to that type of environment.
Absolutely. Looks like the answers have settled. So Nginx came out top, which is kind of what I expected, but we do have a good range of answers here. And someone did put in Envoy at the end as well. So nice. Looks like I got a good range.
Cool.
All right. Thank you everybody for following along with the poll and sharing what you're doing with us. So let's go on to tonight. So tonight we've got 3 talks. The first one from Alex, which is going to be about open policy agent. Second one from James will be using serverless today. Then we'll take a 15-minute break and Kevin will close out with Kubernetes Ingress today and tomorrow. And then we'll close up at 9 p.m. UK time. Thank you, shout outs to our sponsors who keep this meetup running. So I know we've got Ashley on the line from Palo Alto Networks. You want to introduce yourself, Ashley?
Sure, yeah. So I'm Ashley from Palo Alto Networks. That's me. We like to sponsor CNCF because we love all the things that CNCF does. And we provide security. We are a vendor. We do provide cybersecurity, and we do so for lots of CN stuff. But the big reason for being on tonight is that I want to say to you that we are really excited about Cloud Native, and we are hiring. We have a number of different roles in various different parts of the organization. But if you're interested in Kubernetes, if you're interested in serverless, if you're interested in all this cool stuff that we like to talk about, then please check out our website. If you want to contact me for more information, then I'm sure we'll be able to find a way for you to do that. But get in touch, please do.
Fabulous. Thank you, Ashley. Megan, do you want to take over for Technovo?
Sure. So I'm Megan. Technovo is a challenger digital consultancy providing expert partnership and growth without creating dependencies or disrupting culture, just through a sense of community, which is why we're so proud to sponsor Cloud Native London. Community is truly at the heart of everything we do, and there are 2 ways you can find out more info about us. You can chat with me, I'm the community advocate, and you can find me on the Cloud Native London Slack channel. My handle is my name. You can also follow the Technovo LinkedIn page where we post about our latest updates and blog posts. You may have already heard of us as Meetup Mates, but I'm proud to announce our makeover to Tech Camp. Cloud Native London is actually the first meetup where we've been able to share the news, and I'm super excited about that. Tech Camp is one of Technovo's community initiatives, and we're officially partnered with Cloud Native London. The idea behind the initiative is simple. No one should feel like they can't attend the events they're interested in simply because they have no one to go with. Given we're in very strange times at the moment still, a community is more important than ever. The Tech Camp Slack channel is where like-minded devs can come together, discover the latest virtual events happening, and discuss what they've learned. You can find more info at tech.camp. So it's tech.camp, where you can also sign up. And then, yeah, back to Cheryl.
Awesome. Thank you so much, Megan. I believe Humio and X Matters did not send anyone this evening for shout outs, but I want to say thank you to both of those for supporting us. We are now going to take a quick selfie. So apologies if you're on YouTube, this is going to be for people on Zoom. What I want to do is take a selfie and everyone's going to turn on their video briefly while I do this. So, okay, see if we can get this in. So Theo, Kusho, you can turn your videos on. Come on. Oh, okay, stay here. All right, hold it, smile, wave. Oh, hey, sweet. Thank you so much, everybody. Okay. Last but not least, if you want to be part of this, then please come and go to this link, oishell.com/cloudnativelondon, and you can sign up to speak or sponsor or share your own events. And with that, I'm going to hand over to Alex. So, Alex.
Thank you, Cheryl. Let me
You
just
can share your
my
screen.
Yep, coming right up. Let me just open my, cool. Hopefully you can see my presentation. So good evening, everybody. Good afternoon, if you're joining us from the US. I was just laughing with these folks because, quick story, before this meeting, almost like the dog ate my homework, all of my slides disappeared. So I had to redo 37 slides in about 20 minutes. And so it's quite interesting what you throw out. So please bear with me. I haven't produced the lowest quality presentation in the world on purpose. I promise that the content's there, and it's purely that I've tried to scrabble together in the last few minutes. So without further ado, Open Policy Agent, your passport to enterprise interoperability. This talk is about Open Policy Agent, what it is, what it's doing in the CNCF, how it's being used within container runtimes, being used on via virtual machines as well, and how we're using it to enable constraint-based policy and using it to create a common vocabulary across enterprise organizations. So who am I? I am a Continuous Delivery Foundation Ambassador, a DevOps Institute Ambassador, and just generally an open source contributor. In my working hours, I work at American Express as a cloud engineering director, and I spend a lot of my time thinking about how do we get various parts of the business to work well together and be able to move in more of a cloud native direction, which is harder than it sounds. Before we get started, I just wanted to remind you that it's CDCon today. You can register for free. You can check it out online. So CDCon is the Continuous Delivery Foundation's first conference online. Everyone's super excited to go speak. And there are some great speakers. So please, if you've got a free afternoon, go check it out because there are lots of interesting talks on Tecton, Spinnaker, Jenkins, etc. So let's start from the beginning. Most enterprise organizations are extremely complicated places. You have many different tribes, and there's a real diaspora. People have unique goals, unique values. The communication models differ. The opinions on quality and collaboration differ immensely based on who you are in the organization, right? If I'm working within SecOps, if I'm working in CI/CD, we all have ideas of what it looks like to produce a service, maintain that, and work with other parts of the business, let alone creating a process for somebody else to find accessibility on that service. Cloud infrastructure has created an intersection between this new and old, because essentially what it's done is, with cloud infrastructure has come DevOps and the DevOps principles and practices that come with that, the shift left in mentality, and the agency and empowerment of the developer, right? So teams are expecting more. And this is frightening a lot of these anachronistic parts of the organization with their own custom and value systems, who decide that you should be able to use a Jira ticket or a form for requesting a load balancer. This just isn't the world we're moving into. And I think that there's a real tension now in large scale organizations as they split apart from new and old. And I speak somewhat with experience from several large companies that I worked at, in that you'll often find real grassroots initiatives to bring change about and to utilize modern technologies and to think in a very ubiquitous and a very inclusive way. And often that creates fractures within this organization. And I'll just sort of quote Ryan Tomlinson, who actually talks about flow within engineering organizations. And he talks about the core of increasing that flow is the battle between centralized control, which favors alignment, and a decentralized control, which favors autonomy. And of course, the goal is that we achieve both, but the approach towards autonomy whilst keeping everybody happy. So in my little diagram here, my little pictographic representation of our organization, you can see that at the outset, you have at least sort of a dozen or so teams who are all involved in the process of getting to production. From the product engineering team who live in Disneyland, all the way over to the network team who are in Mordor and want to release your product out to the world. You have real problems in traversing that simply. At a startup, you can do that all by having a couple conversations, and you probably have that automated in GitLab or some other tooling that makes it super easy. In a large-scale enterprise organization, that's not the case, because these teams apply Conway's Law, and Conway's Law is a mapping of how we communicate is represented by our organizational structure. And it's correlative in that you see that when you start to have a lot of these structures compounding together on your journey, you'll find that you grind to a halt, right? It's almost like having roadblocks along the highway constantly until you just give up. And so what I want to explore and what I want to talk a little bit more about is how, in our experience, and drawing on sort of previous work that I've done very recently, we've looked at how we can start to find commonality between these teams and how we can start to bring them towards some sort of alignment. And it's difficult, because I mentioned that there are a lot of idiosyncrasies between these teams. It's not that they don't want to work together. It's quite the opposite, actually. Many of these teams are desperate to find a way to be able to plug in their little piece. For example, the SecOps team, they're a large green block in my example here, because they represent a huge voice within the organization. And that is precisely the problem, is that we live in polyphonic organizations, right? We're all playing on the keyboard at the same time, but we're making a real discord in what we're coming out with. What we need to come out with is something a lot more united. And there's research by Schneider and I think it's Zervas in the 1930s who talk about 1970s, talk about corporate communication essentially being multiplied by the disparate voices and creating a real chaos when you're trying to do something on behalf of the organization. So before we even talk about the technology side of things, you can see that there are some fundamental deep-seated differences in value across these organizations. Secondarily to that, there's also a sliding scale of maturity. We've talked about grassroots efforts. The developer community, often with the little flag up there, will be the more advanced community. They'll be looking at how best practices should work. But if somebody in the converged infra team doesn't want to give you, vSphere API access so that you can start provisioning stuff, then you're stuck, right? So our man, Martin Fowler, who, is often a font of knowledge, comes with this phraseology here of, as you try to model a large domain, it gets progressively harder to build a single unified model. And this comes directly from his thoughts on bounded context. And you'll see that a lot of people have made efforts to try and codify and quantify this kind of thing that I'm talking about. And you hear often domain-driven design as being this kind of, lightning rod for how we're going to solve this problem. GraphQL and domain-driven design are going to solve everything. You can put GraphQL in front of serverless and now the entire organization's happy. That's great, but it doesn't solve the fundamental building block problems of various services being able to have their service interface brought into a singular environment where everyone can consume them. You still have to write that additional layer. So if we dig in to what I was just describing in this large-scale enterprise organization, this is a pretty simplistic view of how that organization would work. You have your local development on the left of the diagram, all the way to the right, where you have other concerns. And each one of these boxes, think of it as a thing that they think about at night, right? The SecOps team think about image auditing, Kubernetes auditing, Docker image registry, SHA layer checking. You've got the NetSecOps team who care about firewall egress control and ingress control, global traffic management. And again, as I mentioned, the infrastructure teams who are thinking about all the way up from the hardware layer to the virtualization. They're worried about whether they want to move on to the latest version of OpenStack versus VMware. VMware. So you've got a lot of different people who are thinking about all this stuff. And again, I think what's better to do when you're thinking about an enterprise organization is to model it like a micro society, right? In society, there's no single ubiquitous goal or communication structure. There are more like ebbs and flows of culture and movement occurring within that. And so I think that fits more with the DevOps philosophy that culture is kind of a ripple effect, right? As we start to influence people throughout the organization, we create that ripple effect until that ripple effect gains such critical mass that it becomes a sort of a chorus of voice, to use the previous analogy. And so without that, we run the risk that low value human activities are going to be fueling processes forever, right? Unless we make this change, you're going to have organizational units that have low value activities like checking forms and clicking a button to enable a firewall or to do something with a security option on a VM that lives in a dusty cupboard somewhere. It perpetuates this cycle. By having this activity, you need more people to support it. Every time one of these teams scales up, you then suddenly need more people to support onboarding manually into the CI/CD. So hopefully I've made my point emphatically clear that enterprise organizations fundamentally in technology need a lightning strike of change. And so that's where we started thinking about how do we perform such change? And again, just to quantify here, I apologize for the very basic view here, but you have service interfaces, creating ubiquitous services interface. That's super hard. If I've got an ancient database on a mainframe, I've got a Cassandra database, I've got Kafka, and I've got a bunch of other stuff. How do they all present in the same way? How can I create a catalog of those services? Probably you can't. But there must be a way to be able to make them better in terms of DX. And again, DX is now, developer experience that is now kind of a cultural barometer to which we measure the success of an organization. And I think of people like, Jez Humble in the Accelerate books that have come out a few years back around developer experience really now being the way that and the driving force behind a lot of change in software engineering. Enterprise security, I mentioned SecOps. Enterprise security is a massive one. Enterprise security is a challenge because they are always behind. And it's not their fault. There's more technology coming out than they can ever possibly review. Istio Service Mesh, we've just gone through a period of having that completed in terms of review, but it takes time, right? Because you need to understand the nuances. Istio running in GKE, so Google Kubernetes Engine is different to Istio running on premises. There are very different, stark differences if you're running Calico or some other, interface plugin below that as well. So that's a real challenge. Automation is a challenge in that you might have your CI/CD process automated to deploy your piece of website or backend engineering, backend service out to your E1, so your lower environment, so your dev environment. But getting it to the higher environments, I'll bet 9 times out of 10 in an enterprise organization, it's not automated. And if it is automated, you're calling somebody else's undocumented API. And then lastly here, having a ubiquitous model of delivery also means that we all think in a similar mindset about what delivery means. And again, this harps back to shifting left about giving people agency. It's not about just trusting developers and living in this kind of developer nirvana. It's about being able to make those decisions that are important and reducing the risk, right? You segment the risk. So when I deploy something that's an API change, I'm not at risk of bringing down an entire company's, customer-facing services because of that. And if you are, that is a more deep-seated problem within the way that you have built your software. So with all that said, I want to talk about Open Policy Agent. It's a fantastic project, 5 years old. It's now incubating within the CNCF, and it has an incredible history of taking some very complicated and actually a very competitive space and producing something that is quite simple, it's declarative, and it's cloud native. It's context aware. You know, you can leverage external information to write about policies you care about. You don't have to invent roles that represent complex relationships, you know, that nobody's going to understand. It's superior to ABAC, RBAC, and other standard constraint and rule-based models. And it allows you to create a common vocabulary between teams. Now, before I go further, many people won't really know what I'm talking about when I say constraints and rules. Essentially, think about when you create a simple virtual machine that hosts, let's say, for example, a Node.js image running a server. In an enterprise environment, you would tend to have some sort of constraint saying, I can only deploy that if it's come from a known repository. You know, I can only run that if it's operating with non-root access, you know, and I can only access the external firewall if it's going through this port. These things form rules, right? We have rules in life all the time. We have rules about the time we get up to the time we go to sleep. It's an extension of that kind of human behavior codified so that we can make sure that we're best protecting the business, but we're also best representing how to use our platform, right? The virtual machine owner plus the security team may well be the ones that create these basic constraints. So the need has been there since the dawn of time. It's just that Open Policy Agent has a fresh take on how you make this work for administrators in a fine-grained way across the stack. So one of the primary attractions of Open Policy Agent, or OPA, as it's also called, not OPA like the Outer Planets Alliance, it's OPA. One of the main premises of it is that it uses Rego. Rego is a really simple declarative syntax. What's really interesting about it is that it's extensible, and I'll go on to talk a little bit more about that later. But you can see in my simple example that I've taken from the Rego playground that anything from huli.com can't be deployed, right? It will deny any image that comes into a Kubernetes cluster that is from Huli. So again, this is human readable. It's completely declarative, and it's low cost in that I'm not having to iterate lines and lines of JSON. I'm not having to think about JOTs on the back end. I can actually, as an operator, implement somebody else's policy within my cluster on my machine, and it takes care of a lot of the heavy lifting for me. So when you talk about OPA, we have to think about Gateway, because Gateway is the first class integration with OPA. Gateway is a Kubernetes-centric integration with OPA, and it really brings to the table all of the power that I'm talking about. So if we take a step back and we think about how Kubernetes works, you have generally an API server, which enables a lot of the activities in the cluster to happen. You know, it maintains the controllers, it allows the user to interact with it, it has a lot of functionality. But what it also does, for those who aren't particularly in this space may not know, is it checks anything that goes into the cluster. It has an admission review process where you can add mutating admission webhooks, and you can essentially morph the behavior to extend it to do something else, right? And so OPA fulfills that space with Gateway. It allows you to use the hook in the admission review step to get OPA to validate some part of the schema or the object. It will send back a response, which will either produce a valid schema or an invalid schema, which will go on to the controller to then create that resource in the cluster. And this is really, really powerful because OPA becomes as simple as installing Helm install OPA with a bunch of policies. And out of the box, as I showed you a moment ago, those Rego files, those policy files are rich. You know, you've got a lot of Kubernetes functionality in there. I can check labels, I can check anything I want. I can look at all of the various annotations. And in fact, it's extensible to CRDs. And I'll talk about that a bit later. So custom resource definitions can also be expressed through OPA. So as we started to think about this, we thought, hey, this is some pretty powerful stuff. I mean, you've got essentially a rule-based policy system with an extremely robust library that's extensible. It's written in Golang. You know, the policies in Rego, the data's in JSON. You've got a daemon that can be deployed as a virtual machine host or within a cluster with gateway. And you then have the ability to run WebAssembly runtime with Opa as well. So it's really, really quite a flexible and broad scoped platform. So we took this a step further and we thought, well, if you can have an admission controller in Opa, then you can start to think about what would it look like to have custom policy, not just policy within Rego, but actually modifying the Opa modules and runtime so you could support your own plugins in Golang, right? I have my own package, which is called Alex's ADS check, right? To see, Alex's Active Directory check to see whether or not I'm a registered user. And that's powerful, right? So time of object submission, I can check the service account of the user. I can check the labels that perhaps I put on this resource. And Opa can then go through into its library. Its library might have a web call to an LDAP server. You can come back again and say, okay, yeah, Alex is the real deal. You can let him in. And then you take it a step further. Once that CRD is created, you then have a way for an operator to leverage that CRD to do something, right? So let's think about that and what that really implies. That means that we have essentially got the mechanism for creating a bring your own service in Kubernetes for any part of the organization. That mainframe team might support one SOAP API, right? They may have a very limited API, but they want to bring that to the users. They don't really know how to create an open API spec and a Golang front end and sort of abstract it in that way. But instead, what they would like to do is to say run a serverless function that would insert a record. With Opa, they can have a constraint policy. They can have a module that back to create that table in the mainframe. It might even do some more activity. And then what they can do is use an operator, a service operator, to then create any other additional policies or, any other additional resources that are required. So let's actually look at what that would be like. As a product engineering team, I want to be able to provision a load balancer. And it's interesting. So, my co-speakers here talking about reverse proxies. I might want to be able to provision an F5, right? An F5 is a hardware-based load balancer. So provisioning is complicated, right? I need some information. I need where I am in the world. I need who I am, what my team is, my cost code. Again, this is an enterprise we're working at, remember. We've got to know who's paying for it. All that stuff can be front-loaded in the custom resource definition. It goes into our multi-tenant Kubernetes cluster. Could be single tenant, doesn't matter. Could be on a VM. Opa's running. We've got two policies for Opa here. We've got a cloud provisioning policy and a business intelligence policy. Because part of our constraint in our organization is that we want to know which Active Directory group is deploying F5s because they're expensive. So what we've done is we've extended the Opa runtime and written a BI module that will collect any data. It will look, let's say, for example, it's simple. It just looks at a string table and says, yeah, okay, we know who they are. That's fine. Let them in. Again, the policy for cloud provisioning will check to make sure that I filled in all the labels, the annotations in the metadata, and then check the spec to make sure that it has everything I need. However, this goes a step further. This has a cloud provisioning module, which essentially would then say, okay, I'm going to do one or two checks. I'm going to call out, right? I can do that. And then running it from the module isn't ideal. That's just for admission. Once it gets past there, it's going to do something clever. It's going to say, right, this person here is allowed to go into the cluster, but how do we maintain that chain of custody? Well, I'm going to write to Vault a special token. I'm going to add that special token to the annotation in this CRD. That CRD becomes a resource in the cluster. This cloud operator says, hey, I see this CRD and I can see he's got a special token. I'm going to check Vault. Oh, just turns out I've got a secret. Great. I can actually go and do something with this. And this cloud operator is talking to F5 directly. He can then go and provision an endpoint in the cluster, at which point that product engineering team can go off and utilize this endpoint. It could be a known name, right? So at the point of creation, it will return you, hey, this is your new F5 endpoint. That is just one example. You can go much further with this. So we change. Oops, sorry. So what have we learned so far from this? Well, Opa provides a common vocabulary. I've given a whistle-stop tour. I've shown you how Rego files work, but it goes a lot further. Existentially, it's very simple to be able to say, oh, I understand what a policy means. I can read those policies. They're human-centric. And I know that there are policies that can be reused. You can share them. You can create an appetite between parts of the organization to work on policies together. You can share modules between those policies. You're creating a fabric of delivery, right? Where you're all sort of making this Bayeux tapestry that represents what it looks like to actually deploy something from the product engineering team all the way out to the folks who are working on the production environments. There are, however, various levels of maturity within organizations and also appetite. You'll find probably that when you start to float this philosophy and this idea, you'll get varying kind of mileage, right? Some parts like SecOps might actually say, you know what, we're 3 people and we have to maintain 500 developers worth of work. Let's get on it and we'll do it. You might find that other teams, as I mentioned with these mainframe teams, it's an ideological shift, right? They're sort of scratching their head saying, well, why am I suddenly working with Kubernetes and doing this? However, I've often found that people are like desperate to do this. They're jumping out of their seats, really excited that they can work on new technology and bring it to the platform that they maintain. And what's the third thing that we learned? Well, the future is leading us to having more of this BYOS architecture because it's becoming really ubiquitous with developer experience. At the moment, the kind of stuff I'm thinking of is how do you do this in a Heroku-like CLI kind of thing, right? How do I say provision load balancer within a cluster? How do I codify within my Helm chart everything I need within the infrastructure, right? From that Cassandra database to that F5 load balancer. There are sporadic and incomplete solutions today to do all that. You need to have several major processes. What I'm excited about is in the near future, we're going to have a very similar kind of thing to the sort of cloud packaging that you're seeing prototyped at the moment, but with a real emphasis on it being kind of bring something to the table with a policy, just express how we should be using this through constraints. Thank you so much for listening to me. I am super interested in this kind of stuff. If anybody has any questions, wants to reach out to me, I'm on Twitter, I'm on Medium. I write a lot about enterprise interoperability and other issues like that. I also care a lot about edge and self-hosted, gRPC, and Envoy proxy. So I hope you found that interesting, and thank you so much. And again, I do apologize for the very lo-fi presentation.
Alex, that was absolutely fantastic. Thank you so much for sharing what you've been doing at Amex. It's really great to hear how a kind of real company is using this. And yes, with the lo-fi slides, but no, it's really fantastic.
Thank you.
James, I'm going to hand over to you, but if anyone has any questions for Alex, then please put them in the chat, and Alex, you'll stick around and answer any questions.
Sure.
Yeah.
Cool.
Awesome.
I really liked your lo-fi slides. I thought they were cool. There needs to be more of that.
Not bad for 20 minutes, right?
Yeah, no. It reminds me of that. This is a mother something website domain. If you've seen that, that's cool. Okay, so serverless technology. First, by introducing myself. My name is James Charlesworth. I am an engineering manager at Pendo. Pendo is a platform that helps product managers understand how their product's being used. Provides insights, gathers feedback, offers guidance. If you want to find out more about Pendo, visit pendo.io. If you want to find out more about me, this is my Twitter. If you want to find out more about serverless computing, then stick around. The reason I'm doing this talk on serverless, I watched a debate a while ago that I think Cheryl hosted yourself between serverless and Kubernetes. And it was a battle of which is the best, which is the future, and all that sort of stuff. And it got me thinking that it's not necessarily a battle between serverless and Kubernetes. It's not containers versus serverless. They can work together. And if you've got a system that's on Kubernetes, nobody's suggesting that you're going to rewrite that into a serverless architecture. So I apologize if you've probably seen talked about serverless a million times, but in fact, no, I make no apologies for that because this stuff's important. Kevin said earlier on, serverless is yesterday's technology, and that's kind of true. But if that's true, then why isn't everyone doing this? And I think everyone isn't doing this because they haven't thought of enough ways that they can ease their way into it. Right, let's start with a very quick story about myself. So I am in my mid-30s. I started my career about 15 years ago in industrial control software. And this is the kind of software that runs in factories, on oil rigs. We did cruise ships, stuff like that. And the way industrial control software works is you have something that's connected to the real world, like a switch. And when somebody comes along and switches the switch, that'll raise a voltage on a wire, and the wire goes into a programmable logic controller. And inside that logical controller, you have a function or a piece of logic. The function runs, in this case, it's looking at the input state of the switch. It's comparing it to the state of the emergency stop. And it's saying, if that's all good, then set an output, which goes to a drive. And this is very much an input, some logic, and an output. It's a very purist, visceral way of doing what I see to be kind of core, using software to solve a real world problem. It's simple, it's beautiful. This is what keeps your planes in the sky and stuff like that. Every output can be described as a function of its input, so to speak, that sort of thing. And then over the years, I've moved away from industrial software. I moved to London, worked for an insurance company, did a startup, and ended up working at Pendo now, where I solve a whole different kinds of problems. You know, now I'm dealing with like latency issues, and CI pipelines, and test automation, and customers, you know, difficult things like that. And I often really miss the simplicity of this just logic acting on inputs and creating outputs, like how visceral it is, which is why I'm really passionate about serverless and especially function as a service architecture, because in my mind, it brings it back to this. It brings your business logic just back to solving problems to do with inputs and outputs. What is serverless computing? I think I've vaguely summed it up. It's a bit like the term cloud native. There's a bunch of different definitions for serverless on the internet. I'll give you my brief definition. In my mind, serverless is just using managed services instead of running servers. So for example, if you've instead of got a MongoDB database on a server somewhere, you get rid of that and you use some kind of managed database as a service solution. Instead of running RabbitMQ on a server somewhere, get rid of that and use some kind of managed message bus as a service solution. And crucially, if you've got to execute some logic somewhere, instead of putting it on a server or an API or a service, you use a managed function as a service solution. Now, it's this last one that's the biggest paradigm shift. This is where you really need to rethink your architecture, really to think how your software is actually working. And I will also point out that I'm not saying there's anything at all wrong with this top row. Yeah, RabbitMQ here. I've worked with RabbitMQ for absolutely years. It's wonderful. In many ways, it's got far more functionality than these things I've got the logos for at the bottom, but it does still require you to run a server. You know, same for Node.js. Node.js is brilliant. You can do a lot more in Node.js than you can do in a Lambda function, but you need a server. MongoDB is also a thing, but yeah. So let's, in a classic serverless time, do a brief history of cloud computing, because every serverless talk has to have a history of cloud computing in it. And this is mine. Back in the day, back in my day, everything was just monoliths. Everything was a desktop application, then it became a web application. And in about the 2000s, virtualization became popular. Virtualization wasn't invented in the 2000s, it was invented in the 60s. But as hardware caught up, people started to run virtual servers on much more powerful hardware. And then in about the 2010s, all of these virtual machines moved to the cloud. But something else happened about the same time. When people started moving their virtual servers to the cloud, they started to think, actually, we can split out these monoliths into smaller microservices. And then from the microservices model, we get containerization. These microservices are packaged up. Docker was released about 2013, I think. Kubernetes version 1 was 2015. Can you believe Kubernetes is 5 years old? It feels like yesterday. But yeah, containerization. However, let's get back a little bit and go to this microservices part. Let me just get my pointer. Microservices here. Something interesting happened when people started to split up their monoliths into microservices. People started to think, do we actually need to write all of these microservices ourselves? Or could we maybe outsource some of these things to other companies, get other people to do this for us, and we just concentrate on the core logic? I think the first one to go was probably email. I mean, people haven't been running SMTP servers in years now, you know, like email was very much MailChimp and SendGrid and stuff like that. You just send a message to an HTTP endpoint and it sends your email for you. The next one to go, I would say, was probably authentication. In 2008, Google, IBM, Microsoft, VeriSign, and Yahoo joined the OpenID Foundation, shortly followed by Facebook. And people really started to get this idea that you can actually trust a third party to authenticate and manage your users for you. Things like Active Directory, Cognito, and AWS, you know, it becomes better in almost every way to have a third party that's good at it, deal with your users for you. Auth0 is one of the hottest startups in the world at the minute for this reason. And around about this time, I've drawn a tangent to this timeline. And this is my serverless managed services timeline in true Back to the Future style. The timeline skews here. And we start to see other things cropping up. We see Amazon release relational database services, which is a managed database as a service. DynamoDB in 2012. Azure's got, what's Azure's one called? It's like SQL Server Cloud or something like that. And this kind of carries on. 2014, Google acquires Firebase. Now, Firebase is a full backend as a service. You don't even need an API or anything for this. You can just embed this directly in your front end and talk to the database. It's much more than just a database as a service. But also in 2014, we get the release of AWS Lambda. And in terms of serverless computing, this really is like the iPhone launch. This is what kind of changes everything. And then in 2015, Serverless Framework comes along, which is a way of managing multiple AWS Lambda functions, not just AWS. Serverless Framework is cloud agnostic, so you can manage cloud functions from multiple providers. And in my opinion, at least, it's this top timeline, the turquoise one, that is the future. I think we've reached a limit of containers in the kind of holistic sense of it. You know, think about all the stuff that's going on at the minute. We've got things like machine learning. Are we really going to be running up virtual machines to train models? When you've got IBM Watson in the cloud, you can just upload your model to the cloud and have it run it for you. Edge computing, there was a slide about edge computing. Absolutely, you know, that is essentially a serverless technology, edge computing. Internet of Things, that's an interesting one. That came out of the debate that Cheryl hosted last year, you know, the idea that, are you ever actually going to have a smart toaster that you deploy a Kubernetes service to? Probably not. But could you have a smart toaster with a Lambda function in it? Absolutely. Absolutely you can. These kinds of technologies, this managed, somebody else is managing the infrastructure for you and you just send it your code. That's absolutely the future. So that's the what and the when. Here's the why of function as a service, and here's the why of serverless, because I'm incredibly passionate about this. The first thing is it's the future. It embodies the term cloud native. I mean, cloud native London, think about the word cloud native. Serverless technologies like functions as a service, they grew up in the cloud, they were born in the cloud, they live in the cloud. I'm sure you can get some brilliant third-party tool to run AWS Lambda on your laptop, but you don't need to, and you probably shouldn't be doing that. They are cloud native, and that's what makes them so great. Reduce complexity. So obviously there's this balance that you've probably seen before between productivity and control. When we had everything running on a Linux server, you have full control over that Linux server. You could go down to the server room with a screwdriver, open it up, change the hard drive if you wanted to, fiddle with a fan speed, you could do all sorts of stuff, but the productivity wasn't quite there. Virtual machines come along in the cloud and you lose a bit of that control. You know, like I remember quite vividly the first time I pushed some code to a virtual machine on Amazon's Elastic Cloud 2, it was scary. It was very scary. I just thought, I've just pushed all this production live code to something that I have no control over, really. Like if my laptop dies, if my office internet goes down, I can't just go down to the server room and plug a keyboard into it. I can't, I've lost control over that. And that was a hard pill to swallow at the time, but obviously the productivity benefits that come with that offset the lack of control. And it's generally seen as a good thing. Kubernetes, obviously, you lose even more control. Now you can't even control your operating system or anything like that. Serverless is just another step along this scale. You don't even have control over the infrastructure or the servers. You know, it's this whole thing of the classic joke is serverless has still got servers. It's just somebody else's server. And yeah, it is someone else's server. It's someone else's server that you don't have to manage. And that's what makes it so brilliant. That's where the productivity comes from, is not having to worry about all that. So that's another massive advantage of service. Another big one from a code point of view, and I know we've got some software developers here, is the way that it forces event-driven architecture. And that brings us back nicely to the story I told you at the start of industrial control systems. Because this is an event-driven architecture. You've got an input event going off and a function that happens, and that creates more events in the real world. Something happens, some code runs, something else happens. And Your event might be a customer placing an order. It might be somebody logging into your website. It might be a webhook from a third party you integrate with, or it could just be a schedule. Run this at 7 a.m. every morning, something like that. But it makes for much simpler and easier to grasp systems. I've got an example of this because I think this is quite key. Let's say you've got a web page that allows you to upload a file. So you've got a box on your web page with a file upload thing. Now, traditionally, the way you might have done this is you take this in your front end in your web application, post it to an API. Your API maybe takes the file, stores it in an S3 bucket, and then sends an email out to the customer. So the file is going from your web page to your API to your S3 bucket, and then an HTTP post request is what's triggering your function. And your function inside your API might say something like, when an HTTP request is received, save the file and email them the user. Now, there is an event in this system. The event is the HTTP post request that triggers your function. But that event isn't a first-class citizen in this architecture. That event is almost just a consequence of the way you've built this. So I posit you another way of building this. Let's say you've got your front end where you upload a file, and that file goes directly into an S3 bucket that you've authenticated with separately without any APIs or anything. And then that S3 bucket triggers an event which runs a cloud function, and that cloud function emails the customer. So your file's going from the front end directly into the S3 bucket, and the S3 bucket is raising an event. Now, that function can be written as, when a file is uploaded, email the user. The same consequence, but the bottom one, if I put these two side by side, you can see how this bottom one, the event is a first-class citizen. And as a result of that, we get a much more clearly defined and single responsibility function than the top one. And if you build your system like this, everyone can understand it a lot easier. And the other thing it does is it forces good coding practices. So, event-driven architecture is great. It's a good way of doing things, but it also forces you to do things like stateless backends. Stateless APIs, RESTful APIs is basically the norm now, but up until serverless came along, you still kind of could just hold some stuff in memory and keep state. I've seen people doing clever things with like a Redis backplane on a bunch of Kubernetes pods where they try and share state between a bunch of Kubernetes pods to maintain a session. That's not great. It's not a great way of doing it. And serverless function as a service forces you to not do that. Single responsibility principle. I think I kind of touched on this before, but do you remember 5 or 10 years ago when everyone was putting solid on their software development CVs? The S in solid stands for single responsibility principle. And that's where every part of your system has one responsibility. And function as a service absolutely embodies that. Every function does one thing. When a file is uploaded, email it a user. When an HTTP request comes in from someone else, do this, send an email. Pure functions, reducing side effects. It works very well with CQRS, that sort of stuff. So that's all great. But another point that I really like about serverless architecture is the way it democratizes business logic. And this is something that a lot of people kind of gloss over because they're so concentrating in the code side of serverless and they're concentrating in like how it's implemented, that they kind of forget that by taking your functions and making them first-class citizens in your architecture, a lot more people have visibility around your organization of what they're doing. And that's why I asked this question. There was a big bong earlier on because that was me taking a screenshot of this. But the reason I asked this is because if you look at this, like 35% of you aren't software developers. You're not necessarily being paid to write JavaScript, but you can do it. You can understand it. I suspect there's probably a few people in this 35% here that would understand a function like this. So yeah, you're not an expert on JavaScript. Who's an expert on JavaScript? Of course not. But you can do a bit of JavaScript. I mean, I know product managers that know JavaScript. I know a sales guy that could read this function and tell you what it was doing. And it is so much easier to have a conversation around your organization of what the actual business logic is that you've got. If you can just show people where it is, show people what it's doing, have a function that says what it's doing. Operations people as well. This is a big thing. I mean, DevOps for me is all about empowering developers to do ops, to take to take responsibility of ops. But with stuff like this, with functions as a service, you're empowering operations people to take responsibility for the business logic, for the functions. I know operations people that have written Lambda functions to do things like stripping HTTP response headers and stuff like that. And they've done it perfectly well and they're fine with that. They wouldn't consider that software development, you know, like looking for an IP address range in a Lambda function. So that doesn't make them developers, but you know, if you make those functions, all of your functions like that, if you make every single function like this strip cause header from a request thing, then you've created a larger amount of communication around your organization with what your actual core business logic is doing. And I think that's a good thing, personally. I think that's a really good way to be going. So we've got that. And then the last advantage I want to talk about is cost scaling. Now, this is always the classic advantage of functions as a service, right? You've got a graph of cost against usage. And if you've got a virtual machine running, that virtual machine costs you a certain amount per month, and that's just how much it costs. Kubernetes and things like that kind of solve that problem, you know, like as your usage goes up, your auto scaling can go out, it creates more pods left, right, and center. But Kubernetes, I mean, I've never seen anybody run 0 pods. I've never seen someone scale down to 0. Generally, you're scaling down to 1. So there is nearly always an overhead for running a Kubernetes cluster. And that overhead might not matter. I mean, at Pendo, we process like up to 10 billion events every day. So we're not really worried about the overhead of having 1 pod running. But there are some instances where that actually can be a problem and it can stop you innovating. Serverless, the graph of serverless looks like this. On the left-hand side here, it scales down to absolute 0. If you're not using your system, then it doesn't cost you anything. And that can sometimes, in a few situations, be incredibly important. And I'm going to show you a case study. So I'm going to show you some stuff that we built recently, and I'll show you the billing pages of a website we built for, let me just see if this video starts. Yeah, this is a website I was involved with recently for local bands and musicians in London. And it's kind of like a message board. It gives people the opportunity to create posts, so that they're looking for a bassist, for example. It's got articles and stuff like that. And when we wanted to do this from the start, we wanted to make this a community project. This wasn't a money-making thing. We wanted it to be completely free. Like, we didn't even want to have advertising on it. We wanted it to be like Wikipedia, where it was just for the community, user-generated content, and it manages itself. And a website, like any business, if your business model is that I don't want to make any money, then the only way you can make that viable is if you don't spend any money running it. And so this really is the bottom left-hand side of that thing we were talking about, of the graph, because a website like this is our billing page for this, right? This costs us 63 cents a month to run. It's just in London. We get a few hundred visitors a week. The majority of people just browse the website, but a few people, one every couple of days, will create a post and they'll engage with each other and they'll message each other. And it costs us next to nothing because of the serverless model we've built it on. And this is what I'm talking about, small community-based projects like this, where the bottom left-hand corner of that graph is crucial because it's the only way you can keep these things running and not have to bankroll them yourselves. Here you go. I'm going back to show you the bill from April to show that it's been like this all the way from the beginning. So the way we've done it, and I'm going to quickly talk you through the architecture. I think we've got 10 minutes left, so I'll be quick about this. But the way we've done it is most of the website is just S3. So it's just HTML pages. It's a static website. When you navigate around the website, you're going through a CloudFront into a bunch of HTML pages in S3. And there's a million ways to host a static website with relatively low traffic volume for free. You can use things like Netlify, GitHub pages. We've got this on CloudFront because we're well within the AWS free tier on this, so we're fine. However, this isn't just a static website. It still needs to have a backend. It still needs to be able to create posts. People can send each other messages, that sort of stuff. So our serverless backend for this, I'll quickly talk you through how this works. If you go through the website and you create a post, what that will do is when you've created an account, you'll get your own private area of an S3 bucket. And you go through here, you add a photo, you add some information, and you click submit. And all the information about your post will get packaged into a JSON blob and a photo and put into your private area of S3. And just like that example I showed you before of an event-driven architecture, once the S3 blob has appeared and it's been checked for things like spam, an event's triggered. And that event runs a Lambda function on the back end. And the Lambda function in our case is called render HTML. Here it is. And this Lambda function has got the entire React package built inside it. So this will read the JSON blob that somebody's just submitted, and it will create a new HTML page and put that into our public S3 bucket. So it works a little bit like next.js, if anyone's used that. It's a sort of static website with dynamic elements to it. So you can, on the fly, render new pages and re-render pages and stuff like that. And that means that we're only paying for every time somebody creates a post, which isn't hugely often, or we're creating for every time somebody sends a message through the website, for example. That's another Lambda function that gets triggered saying, oh yeah, here's a message. Our messages, when people are chatting to each other, they're actually going to DynamoDB. Obviously, they're not in S3, but DynamoDB, it's another pay-as-you-go database. So we're only paying for the number of transactions, the number of reads and writes, and a very small amount for storage. And again, we're well within the free tier on this. We get a couple of people messaging each other every day on this website. And again, well within the free tier, small community website built on serverless. Incidentally, if anyone here is in London and is looking to join a band, this is a really good time to do it because practice rooms are starting to open up. And COVID almost demonstrates my point perfectly. A website like this for people to get together and join bands in about March this year became largely irrelevant. Like, there was no live music going on. All the rehearsal rooms shut down. Nobody could meet up and jam with each other. Like, it was literally illegal to do that. So our traffic on the website went pretty much to zero. Nobody was creating posts. We had about 3 months with 0 people creating posts. So we genuinely did scale down to 0. For a few months, this website had 0 traffic, 0 Lambda functions being executed, 0 messages being sent. But again, that's not a problem because we're on the bottom left-hand side of the cost versus usage graph. It worked really well for us. And let me just end this video. Yeah, that's it. So, disadvantages of serverless. You've heard me talk very passionately about how great serverless technology is and about how everyone should be using it, but ultimately I'm not an employee of serverless framework. I am going to lay out some of the disadvantages, and the biggest is vendor lock-in, and it's a very, very extreme form of vendor lock-in you get with serverless. This isn't just, we're using Sentry.io to send our errors to. Oh dear, we've been vendor locked into Sentry.io, we have to change it to another. This is very, very severe. If you're on AWS, you're probably going to end up using every product that AWS has, and that's bad. That's bad for innovation. It's bad for, well, I mean, I don't need to profess all of the disadvantages of vendor lock-in, but yeah, it is an issue. There are things like OpenFaaS. I could do another whole talk on OpenFaaS if Cher will have me back. But yeah, there are a few solutions out there to try and combat it, but they always seem to be swimming against the tide. Anything that tries to combat this vendor lock-in, one of the 3 big cloud providers would just bring out more features, and they'll just do something a little bit cooler that entices people back towards them, and they're doing that for a purpose. But vendor lock-in, yeah, absolutely, that is a disadvantage of serverless. Another disadvantage, famously, is the limitations placed on things. If all of your code is in, Google Cloud Functions, there's memory limits, there's cold start times, there's a lot more. There's even like runtime limits. Like you can run .NET, for example, on AWS Lambda, but only .NET 2.1, whereas the rest of the world is on .NET 3. So you're always kind of limited by what the provider of your function as a service thing has let you do, and that can be a real problem. Another limitation is simply that it's different. Now, I don't know your CTO, but I'm fairly sure if you go to your CTO and say, can we have 8 months to re-architect our entire system as a serverless application, I'm pretty sure I know what their answer will be. Their answer will be no, because they'll just see the benefits as being very, very small. And do you know what? They're right. It's not worth re-architecting your entire system into a serverless model. So a lot of people just leave it at that. They just go, oh yeah, serverless is great, but we haven't got time to rewrite everything. Which is why I really, really, really want to talk about some of the ways that you can augment some of your existing container-based stuff with serverless. Let's have a look at an example Kubernetes cluster. Here we've got something with like a load balancer and Ingress in it, a couple of APIs and a couple of message consumers. This is fairly typical for sort of small application running inside Kubernetes. If you look at these message consumers, they might be like Kubernetes cron jobs or something like that. If you look at those, they are basically fitting this event-driven architecture that I spoke about before. They are absolute prime candidates to take out of Kubernetes and put into the function as a service platform. Like if you can keep them in the same code, you can take your libraries with you, take everything with you. You can use serverless framework to manage them, or you can use Terraform or something like that. Yeah, that is absolutely a way where for a very, very minimal amount of work, this is a quick win. This is just saying any part of our system that is already event-driven, that is already just consumers responding to messages, we can put into a function as a service and get some of the benefits of that. These things can scale down to 0 now. So that's great. Another thing you can do is anything that you just need to install and run. So, you know, a lot of this might seem trivial. Why am I using Raven, hosted Raven and managed Raven instead of just putting Raven on a server? But it's a paradigm shift and it's a mentality shift within your organization. Every time you move something from something that runs onto a server to a managed version of it, you've taken away a server that you have to worry about. And if you keep chipping away at this, if you keep moving stuff over, eventually the only servers you're running are the things that are running what is by then just your legacy application. You can ignore that for the time being, and just, you know, get to the point where you're not having to pay people to fret over installing operating system patches, for example, or anything like that. Build servers. This is a really, really super easy one, you know, like I can't really do a show of hands because we're on Zoom, but who's still running Jenkins on a virtual machine or something like that? Like there's so many ways you can do build servers that are just somebody else is managing the actual server for you, and you're almost paying for like continuous integration as a service. Things like Google Cloud Build, AWS Code Build. Here we've got Circle CI hosted. This is what we use at Pendo. It's great. Nobody has to worry about that server. You get a lot of these advantages. I mean, I know people usually talk about function as a service when they talk about serverless, and that is what I've been talking about as well. But serverless is really just removing the servers from your organization. So doing this sort of thing can kind of chip away at that iceberg until it's all gone. And pieces of new functionality. So if you need to add a new function into an existing API, why not just do it as a cloud function? We had this, I used to work for a popular price comparison website, and we had ratings, like user review ratings on all of the results on our website. And those ratings were cached from the ratings provider, I think Trustpilot, and we cached them maybe 2 or 3 times a day. That was just a cloud function that ran. We could have put it into the API, but we thought, no, let's just write a completely separate cloud function that connects to this ratings provider and caches them in our Redis server, and there we go. And you can manage that with serverless. You can put that in the same serverless application as the cloud functions that I mentioned earlier that are stripping HTTP headers that your ops guys have written. Everyone comes together in one service application. HTML page rendering, classic. This is where edge computing comes in that we talked about earlier on. But do you really need to be rendering an HTTP page at runtime on your server, or can you kind of pre-render it on the edge using a cloud function? Kubernetes cron jobs, I think we've spoken about briefly, but anything that's just running on schedule and doing a task is absolutely perfect use case for a cloud function. And then, yeah, lastly, just stop putting everything in your cluster, right? I think I'm basically running out of time, but I just really, really encourage you to think about ways you can add function as a service into your existing tech stack, ways that you can create that new feature as a function. Even if it's a little bit more development work, you'll thank yourself in 10 years' time when this becomes a feature. You know, anything you can do to reduce the number of servers that you have to manage, anything you can do to stop your cluster just getting bigger and bigger and bigger, and your Kubernetes cluster just ballooning. Yeah, absolutely. I encourage people to think about that at every opportunity. And I'm going to leave you a little meme, I think is the best thing. So Kevin's next. Stick around. He's doing a little competition. You can win a £50 Amazon gift voucher. Is that right, Kevin? You're on mute.
Sorry. Yeah. Thank you. Yeah, $50 Amazon gift card. So I think it is US dollar. I don't know.
Yes.
Who knows?
Awesome. Thank you so much, James. That was fantastic. And I saw someone on YouTube also said an Open FAS talk would be great because you mentioned that halfway through. So if you'd like to come back and talk about Open FAS, you would be very, very welcome. All right, we're actually going to do a 15-minute break now. So get up, stretch your legs, and we are going to listen to a little bit of music while we chill out. And don't forget to sign up to the Slack channel. You can go to this URL, and yeah, we got a few hundred people chatting there. So yeah. And also feel free to just keep chatting and put any questions in, and Alex and James will still be here for a little bit longer, I think.
Yep, I'm hanging out. I actually really enjoyed some of the explanation James gave on that talk. I thought it was awesome.
I really like the way that you used the poll that you did at the beginning, James, like in the middle of your talk. It's the first time I've seen that. That's brilliant.
Yeah, that's some next level editing skill.
I had a bit of a weird question that I wanted to ask, like going back to that toaster analogy in one of the presentations. I was wondering, can you write a serverless function to run Doom on a thermometer?
I assume, James, that was to you?
Yeah, sorry. There's just sorry, my microphone out. Probably. I mean, you can run Doom on pretty much anything these days, can't you?
Yeah, that's true.
What's that
I think I
subreddit?
saw somebody run it on a pregnancy test once.
Yeah, that's the one I think I was thinking. I think it was either a thermometer or a pregnancy tester. It was one of the two, but yeah.
Something absurd, yeah.
So when I'm using a little bit of break, I would like to encourage everybody to smash that like button, click subscribe, and don't forget to the bell button, and so you will not miss any next CNCF meeting in London. Only here, only on Zoom and YouTube.
Thank you, Hubert, I think. I don't know. I'm too British, I think. I'm a bit too embarrassed to be like, smash that like button.
Well, you know, as I said,
Thank you. You can be my hype man from now on. You can be there.
I'm
Like,
thrilled if they, you know, if this would be something what I could do. You know, you can always count on me that in the break I can encourage people to to smash that like button, click subscribe, and don't forget the bell button.
wow, you've got this
British
down.
version. The British version will be something along the lines of, if you wouldn't mind, Toby, sorry, but could you possibly like this video?
I'm sorry, but
Very
between the
apologetic.
sips of
Yeah.
my tea, let me that will be splendid.
I don't want to inconvenience you, but cake reveal at 10 million subs. We'll be waiting a while, I think.
Stay to the end to find out what Cheryl really thinks about CNCF.
While they pay me, only good things. Only good things. But it is weird though. It's like I've had to sort of become a bit of a streamer. You know, one day I'll figure out OBS and actually like go full streamer.
Cheryl, are you on Twitch yet?
I'm not on Twitch.
I feel like that's the next platform for you to conquer.
Next month, Cheryl, it's got to be on YouTube, this, and it's going to be on Twitch.
Cheryl plays Among Us on Twitch. I'm waiting for it.
I actually just played Among Us for the first time like 2 days ago, and it is actually kind of amazing. It's kind of addictive. I think I was up to about 4
Who don't
a.m.
know what Among Us is, can those who have played it explain? I've heard of it.
It's like a top-down kind of isometric spaceship game where you have a group of people, and a number of those people are imposters, and it's your job to perform tasks on this ship whilst the imposter is trying to go around and killing people, and you kind of have to vote out who you think the imposter is. That's a pretty bad explanation, but it kind of summarizes it. It's a lot of fun because it's kind of a pick up and play game.
I'll post a meme in the chat which kind of describes it in quite some detail. Give me a minute.
I have a couple board games that kind of follow that whole secret identity type pattern to gameplay. They're a lot of fun, especially in person, but nobody can do that right now, so unfortunately.
It was one of the best, those kind of, oh, sorry, I switched my video off earlier. It was those kind of Zoom, having a drink with friends things that got old really, really fast. It was the one thing that really refreshed it for me, was that we would play this among us and have a chat and go like, I can't believe you. Oh, I can't see who it is. Oh, never mind. Anyway, let's just continue for a little while. So yeah, it was great fun.
Yeah, there's a game for virtual reality called Pavlov, and there's a game where you play, you're either a terrorist or you're not a terrorist, and you have to figure out, nobody knows who the terrorist is, and you have to try and figure it out who it is. But of course, it's a first person shooter, so everybody has guns, and it's a lot of fun. But of course, you got to have virtual reality for it, so it's it's not like you can get a bunch of your friends to play it.
Yeah, that's the nice thing about Among Us, because you can just get it on your phone, or I think it's on Steam and a few other places. And then you can just sign up to like public servers and public games. It's really easy to pick up and play.
I tell you find out who your real friends are on that pretty quickly.
I don't know. I think Alex sus on this. Let's just vote him out. Sorry, that was the other big meme, wasn't it?
Absolutely, yeah. The irony is that my slides have all just been restored. I can't believe this.
So I think we've got 10 minutes. If you go really, really fast.
I cannot believe the timing here. The guy just come back and said, "Oh yeah, sure, I'll just restore your slides for you." Like, no thing.
You did amazing, Alex, to sort of put that all back together again in 20 minutes and present it.
Thank you. I don't feel like I did it quite the credit it was due, but I'm glad it was well received.
I also do want to see the new slides. You're like that. These are the original ones, and you're going, they look the same as the.
Yeah, that would be kind of telling if they're worse than the ones I knocked up.
Kind of goes back to that old kind of saying, doesn't it? Here's one I made earlier.
Always keep a backup, right? Like,
absolutely,
just in case, especially for a new tool, new service. Run both in parallel.
Absolutely. I mean, I've been testing out a few of these presentation platforms. I have no particular affinity with any of them, like Projector, Pitch, others. Good old Google Slides hasn't let me down yet. So I think that's tried and tested, right?
Sorry, I'm just laughing because someone commented, "Real slides reveal at 10 million subs." I'm feeling pressure now. I'm feeling like I need to get up this number. When I first was doing these virtual meetups, I was looking for a cooperative game that people could play together, like 50 people or something. And I didn't want it to be I kind of wanted it to be a cooperative game because I didn't want people to be like super competitive against each other. And I still haven't found a game like that. So if anyone knows of a really easy to pick up game, like please let me know.
Rocket League is one.
Among Us.
But Rocket League, you need to pay for it, right?
Oh,
Download stuff in advance. I don't know.
Never mind. I guess
I would like to say that please.
I'm sorry, I interrupted somebody. What were you saying?
No. I'm sorry. I think I interrupt you. So please go ahead.
Oh no. I was just saying that I thought Rocket League was free to play, but I totally could be wrong. No, it's free to play.
You're reminding me of this post on Medium where somebody's talked about how to make online conferences better. And one of those is a game called Rambly, where you can walk around. It's kind of like an 8-bit kind of thing. So you can just be in the conference whilst walking around, talking to other people from the conference. It's a very weird concept.
That sounds pretty fun. I'll check it out. Thanks, Alex.
Let me thank you the actual thing. Yeah, Rambly.app. It looks really cool.
Do you talk to
It's a
people
90s style video game.
Do you just message each other, or do you actually chat to people?
So this is the cool thing. Yeah, you use audio. So you're walking around in this 8-bit world and you hold down, I guess, spacebar or something. You can talk to them.
Well, I've heard like, there's like I haven't done it before. Only thing I've done like that was multiplayer in VR that was kind of like sit down and just chat is poker, where you're at a poker table and you're just playing poker. But I've heard like virtual reality chat, they have these, you can go in and out of rooms and you can engage with people, and the whole audio sensation and being able to look at people in the eye is pretty interesting. It's a lot like real life. I haven't tried it. I've been wanting to. But again, you have to have a big bulky headset and it's not really practical.
Yeah, that is the thing. If everyone needs to get some kind of VR headset in advance, like people can't just pick it up and play it quickly and then put it down 15 minutes later.
At the beginning, we were worried about how you send a pizza to someone, far less a full VR outfit.
Drone delivery.
Yeah, that's what I was laughing.
Weren't they doing some kind of, Amazon was doing some sort of trial of that in London? I feel like I've read that somewhere.
I think it was either Amazon or probably Domino's.
I know that in Australia, actually, they start to using a lot of drones for the delivery, especially on these remote towns where they're really far away. But the only thing about we like the idea, the drone will deliver it. But if I want to ask if any of you use the drone or play with the drone, and know how this how to being around the drone, basically. That's my question.
So you're supposed to pass a test here in the UK now. You're supposed to get a license. It's meant to be a simple thing to do, but you're meant to get it. But that's as far as I got, because of course my son wanted to do it, so I took him through the test. And yeah, that's as much as I know, and it's not very helpful.
My answer is one. It is extremely loud. Doesn't, and we're talking about if there's someone play with this this one brand, what every single YouTuber is using. no, they're not paying for CNCF, so I will not say the name. And I was in the place where someone was shooting, and even if this drone was far away, you can still hear it. And that's what the people in Australia was complaining. It is actually quite loud, especially this one, what they are for the delivery. So I'm curious how this, how if we'll have a land fields, outside of the town for the drone to deliver, and then someone with with a motorbike will deliver it. That would be pretty interesting, and probably keep the economy going.
I know all the laws about drones are like you're not allowed to fly them within a certain number of meters and all this sort of stuff, which basically rules out all of London. I don't think there's anywhere inside zone 3 that isn't either on the flight path to London City Airport or it's within 500 meters of a building or something like that. So yeah, you basically can't fly a drone in London legally. Anyway, legally.
And until they change the laws or the regulations around that. And somebody commented on the noise. Have you ever seen like one of those fans that go in a factory and they're really powerful, and you turn it on full blast? That's what drones sound like. They're ridiculously loud. So who knows what the government will do.
I live near Gatwick Airport, and I remember that there was a big hoo-ha last year because somebody, like you said, flew it too close to the airport. But it ground all industry to a halt nearby because obviously like food orders weren't going through because planes weren't flying, and it's just incredible. And they couldn't locate, and I guess that's partially why they've brought in this new law. And also, I don't know if you've seen, there's actual weaponry to bring drones down now. Pretty amazing.
There's a net. I saw something about a net where they basically shoot big.
There's microwave guns now.
Microwave guns, yeah, they shoot high power microwaves. That's crazy. Well, and they're supposed to make it to where now the drones have special command like chips in them. If they go near those restricted airways, they'll just land. They won't fly. But of course, anybody can override hardware and software. So
I would love to chat more about drones because I very much want a drone, but unfortunately we're here to talk about Kubernetes, so I'm going to take us to our third speaker, who is Kevin.
Hello.
If I was a proper influencer here, I would say like, oh, send me a drone. Like, I really want a drone, send me a drone. But hey, not gonna do that. All right, Kevin, over to you.
All right, thank you, Cheryl. I'm glad to be here. So, hello, everyone. I just want to thank everybody for hanging out, taking the time to come and see this talk. So this evening, I'm going to cover some of the recent changes to Kubernetes Ingress and share some details about the proposed evolution that's being worked on right now to the service APIs. So just so you know, the slide deck is available at this link on the slide. I will share that in the chat, both on YouTube and Zoom here at the end of my talk. And also, I'll be sharing a link to the $50 gift card giveaway at the end of this presentation. So you just have to stick around for about 30 more minutes and you can sign up for that. So just to share a little bit about myself, I work for a company called Traffic Labs. We just recently renamed from Containous to Traffic Labs, but we are the creators and the maintainers of Traffic, also Traffic Mesh, Service Mesh, and Yagi, which is a Go runtime interpreter. I'm also an organizer of Cloud Native Nashville and DevOps Days Nashville, and I've spoken on topics like observability, DevOps, software development, a number of times over the past few years. And I've done several workshops on monitoring and distributed tracing as well. I am an avid cyclist, and I also enjoy an occasional impromptu hike every now and again. I'm also the co-founder and a principal SRE consultant for Single Music, and they are a digital music and live stream provider based here in Nashville, and we started that company in 2016. You can actually read more about Single Music and our cloud native CNCF journey on the CNCF blog. I wrote a pretty long blog article about all the stuff we do there with Kubernetes last month, and I included a link to that at the end of this presentation as well. So as I mentioned at the opening, I'm going to cover the current state of Ingress, including some updates that have happened over the past couple of releases. I'm also going to talk about a few notable changes here because there were a number of updates behind the scenes, which you may want to dig into if you're looking to upgrade to the most recent version of Kubernetes. In addition to the current state, I'm going to cover some of the challenges of Ingress and how that the work being done now under SIG network service APIs is actually poised to solve some of these problems and abstract away some of these crazy configurations that we're seeing in Ingress these days. So before I get started, I think it's always good to cover some basic material, some groundwork for those attending this talk who may not be very familiar with Kubernetes, or they're just not familiar with configuring and exposing services. those who are familiar with it, we're not going to go very deep. I'm not going to do a primer on networking. That would take hours, but I'm just here to kind of highlight some of the fundamentals of what I'm going to be talking about this evening. So Ingress resources allow Kubernetes operators and application developers to expose application services to the outside world. Now, these are typically combined with load balancers, whether those load balancers exist in the cloud, such as Amazon ALBs and ELBs, or on-premise with an entirely software-driven approach, such as Metal LB, or like a self-provisioned edge, such as an appliance like an F5 or a cluster of proxy servers. I'm going to be using Metal LB today in my demos because I'm running traffic on an installation of local Kubernetes and Docker. And I'm going to talk a little bit about that setup during the demo portion of this presentation. So Ingress controllers typically accept incoming requests from the internets, and that's through a network gateway that's been provisioned an IP address. And those requests are usually like layer 4 TCP or UDP packets and or layer 7 HTTP requests. Now, these requests are accepted by the proxy software running on the pods deployed by the Ingress application. And again, as I mentioned, I'm going to be using traffic today as my Ingress controller. Now, the proxy software is configured to match rules based on the details of the request, such as host name, path, like the server name, headers, and the traffic or Ingress controllers will also handle other concerns such as sessions and cookies. But ultimately, it's either going to get forwarded to the appropriate downstream service to be handled and responded to, or it's going to be rejected outright. So it's going to handle things like returning an error code and closing out the connection. So I'm going to cover some of the changes using real-world examples here in a moment. But first, I'll explain some of the notable changes over the past 2 releases of Kubernetes. So the first one in 1.18 is that a path name field or a field name path type was introduced. And this was done to potentially solve an issue where even though regex was an option for paths, the standard which had been chosen by the Ingress committee, I guess SIG network, was actually incompatible with a lot of different Ingress vendors. So the value for this field can now be exact, which, as you might expect, allows you to match an exact path. Also, it can be implementation specific, which then you can put whatever kind of regex that corresponds with your Ingress provider in that field, or it can be prefix, and I'll cover what prefix is in the demo. So also prior to 1.18, whenever you wanted to have multiple Ingress controllers inside of your cluster, you would use something like a ingress.class annotation to specify which Ingress controller that would pick up your service's Ingress. This is now handled with the Ingress class resource, and it allows you to assign a default Ingress class as well. And finally, the last thing in 1.18 I want to talk about is that there's support for wildcards on the host field definitions. Now, in 1.19, some big stuff happened. The big one is that Ingress has graduated to stable. So that means everybody can use it in production now. Huzzah. Some of the field names have changed. We'll cover those in the demo coming up. And one of the things that's pretty cool, and I haven't had a chance to try this one out yet, is you're now able to reference objects like a bucket, like an S3 bucket, in addition to service backend. So you can point, you can point an Ingress controller at an S3 bucket, and it will serve content from that. There's a few additional changes in this release, and you should check out the PR here using this link. If you didn't catch the slide link at the beginning, I'll post that at the end of the presentation. So before I get started showing you the demo, let's kind of explain how this is set up and how this works. I'm going to use a couple of tools to make it easier to expose my services on the internet. So any of you at home can actually go to these URLs and poke around if you want. And what this does is it helps me work on services within Kubernetes in a similar way to how they'd actually be deployed on a production cluster. Now, the developers who work on single music applications, they use a very similar configuration in their local environment so that they can manage the development of dozens of microservices that integrate with real third-party service, like dozens of third-party services that we have to have a system that is on the internet to talk to them and do webhooks and API integrations. So in this example, I'll be using Kubernetes and Docker, which is a distribution of Kubernetes that installs on any typical Docker installation, whether it be you're using Windows, Mac, or Linux. And you can run multiple manager and worker nodes on it, and it's kept up to date because it's still used for running continuous integration tests for all the official Kubernetes builds. In addition to that, I'm going to be using Metal LB, which is a software load balancer, and that's going to install a actual load balancer controller on my cluster that Ingress controllers can pull IPs from, and it's all addressable on my local machine. And I'll show you how that works in a moment. And that all ties into my traffic ingress controller. So let's take a look at how that works. So if we inspect the kind of network that was provisioned on my machine, we can see that it was given a subnet address of 172.21.0.0 and with a pool of 16. Now, anything that gets created within that network should be addressable at that address. So if I ping 172.16 .255.1, well, that might not work from here. No, because I have to be internal. Okay. All right. So, and also ping's not running. So that's not going to work. But it is actually running because if I do curl, oh, well, it would help if I did the right address. So yeah, I can curl that, and if I ping that as well, that should work. Well, ping might not, but curl did. Curl gave me a 404 because that's where my controller is running. So if I look at the configuration map for Metal LB, we can see that I've provisioned a pool of addresses between 255.1 and 255.24. And if I look at deployments, or rather services, and I look at traffic here, we can see that that load balancer was assigned that IP. And ngrok is pretty cool because ngrok actually creates a tunnel on the internet, which allows me to address my this network space on my local machine. And I can pretty much port tunnel or port forward any request that comes to these addresses. So if I go to traffic.kevincrawley.io/dashboard/ this will load what's running on my cluster. And you can go to this address as well, and you can see that this is available to you as well. So that's how I got my local environment set up. And I know it's a lot to take in, but effectively what I'm doing is I'm using my local development machine as an internet addressable Kubernetes cluster. This ends up replicating a lot of plumbing and manual configuration that I would otherwise have to do in a local router, set up port forwards, node ports, configure DNS, and possibly even have an additional software load balancer. But the reason I like this setup is because it's fairly easy to use once you have it up and running. It's replicatable. And at the end of the slide deck, I'll have links to all this stuff so you can set it up yourself on your own machine if you wanted to. All right, so here's a basic example of Ingress. And I'm still using the beta API, which is in 1.18. Ingress class name here has been referenced, and that's actually deployed with the latest version of traffic in the Helm chart. And it's also worth noting in this example, because I'm going to call it out later, that service name and service port are still what we're used to, which is the camel case. That's going to actually change in 1.19, and I'll show you a demonstration of that. So I'm going to go ahead and deploy this and walk through how it all works. So first, I need to deploy the service that I'm going to route to. And let's take a look at the code for that real quick. So who am I service? It's just a simple deployment. It's deploying a who am I container that will echo back to me some details about the request. And we're also deploying a, did my computer just freeze up? Oh no. Yeah, my computer's locked up. If y'all can still hear me, I have to reboot.
No worries, Kevin. Okay, looks like Kevin's video is gone as well.
Someone didn't like and subscribe. That's what the problem was.
No, that's the DDoS.
Right.
When you give you the IP address away.
If that was it, I will laugh forever. Sorry.
Only master hackers can get the local IP address there.
Thank you. That was nice.
Okay, I guess we chill out for another couple of minutes while Kevin reboots and we come back. So sorry everybody for the AV problems.
I would be really interested to know what other people's experiences have been with local kind and Kubernetes development, because one of the big advantages in what was just being demonstrated there is you don't need to provision underlying metal LB to reconcile ingress requests. So that's a big thing. Whereas Minikube shares through service lists and you can do port forwarding, this seems like a really clean solution. So I was just wondering how other people work locally.
So my computer froze up. I'll have to start everything over. All right, let's see if I can get the audio back. Sorry about that.
No worries,
Kevin. We
Kevin.
were just chatting.
Yeah.
All right.
Yeah, Alex was just saying it looks like a really clean solution. So it's
Yeah, I
interesting to see
love
if other people have
Kubernetes and
opinions.
Docker. Yeah. But let's see. Let's see if I can get this up and running. I have to start my environment up again. It'll take a few minutes. So
I was complimenting your tool K9S, which looks amazing. I never seen that.
K9, yeah, I mean, there's a lot of different solutions that can help you visualize Kubernetes, but I try and stay text-based as much as I can. Like
Also
I've
has
used
great-
Lens before. I don't know if you've used Containous Lens. They got bought by somebody, Morantis, I think, but they open sourced it, and it's pretty cool.
K9s has like Vim key bindings. It's really good.
Mm-hmm. One of the interesting things about K9s, or not K9s, but Kind, is it should be able to come back after just a reboot, but who knows? We'll find out. So Kind is up and running. see if I can see the load balancer here. Sometimes it'll provision a new network on like a new subnet and it just breaks everything and I have to wipe it. Which I don't think that's what happened. But I'm not seeing what I should. No.
Did it make the sacrifices to the demo gods?
It did, but I think I can get it back here in very short order, thankfully. Let's see. Because I wasn't too far into it, so I should just be able to reprovision everything. So let's go back to where we were. So as I mentioned, I'm going to be deploying this here in a moment. And what we'll be able to see is, as of right now, it's griping about privacy, but it should come back, is this will be accessible in a moment.
We do have about 5 minutes left of the meetup.
Okay. All right, well then what I will do is, so part of the problem with Ingress is that there's a lot of concerns when you start trying to configure things like TLS, host and paths, redirects, trying to do load balancing, set up session cookies. There's a bunch of stuff that you have to configure through annotations. So this typically goes into like one of three places. And they all have something in common, but that's not really necessarily a good thing. What you're going to see across most Ingress controllers is the configuration lands in like one of three places. It's in the annotation field on the metadata property of an Ingress resource, or it's in a configuration file that's loaded by the Ingress controller and is referenced in an annotation. Now, in modern Kubernetes, like in the past couple of years, we've had CRDs come along, and they've made the configuration of something as complex like an Ingress controller a lot more manageable, but these all things kind of share something in common. And the problem is that they're provider specific and they're incompatible with each other. In addition, they're exposing a ton of operational concerns to developers, like the end users, the application developers. They don't necessarily need to worry about configuring TLS certificates, ports, endpoints. These are all things which application developers, all they really need to know is what path do I expose this application on, or what header do I match on. All the other stuff is just operations. So one of the things that we're going to see that in 1.1.19 is that API version is now stable. So the API version has changed. And remember, service name and service port, they're no longer camel case. They've been broken out into their own field, and they have a name port number 80. So I can actually deploy this now because things are actually running now. So kubectl apply let's get the service running. And Ingress basic prefix. And if we go to, I'll walk through the actual configuration of the stuff here. Now in this example, annotations are being used to configure the Ingress resource. So we have a web secure endpoint. We have some middleware doing some kind of operation like stripping a prefix. We've associated it with a TLS, and we have a certificate resolver so that we can grab Let's Encrypt certificates on demand. So if we go and look at the dashboard here, and I go and take a look at the router for this particular service, we have the API who is it. We can see that this has been associated with a TLS certificate. It does have that middleware assigned to it, and that's all been configured, and that's great. I can actually go to this page. And one of the things to notice here is, like, even though I went to this URL up here at the top, it actually shows that I'm going to /whoami, and that's because of that middleware. And the traffic proxy has put that prefix into a header so that programmatically, if you wanted to do a redirect, you still have it. The application would be responsible for handling it at that point. Now, before I explain how that middleware works, one might be asking, how does Acme Resolver and traffic entry points get configured? Well, it's done on the proxy side. So if we look at the configuration for the proxy itself, at services, and we describe traffic, we can see that we have the web port open at 80, and it's pointing to the container at port 8000. We have web secure at 443, and it's going to port 443 on the container. If we go back to pod and we look at the traffic pod itself and we describe it, we can see that those ports are set up on my container in the service or in the deployment manifest. And then I've also got some command line arguments that are setting these things up as well. And that's really complicated. Like, why does an application developer need to know all this stuff? They shouldn't, right? This stuff should all be handled dynamically at runtime. And the good news is that's actually what the service API is supposed to solve. Now, before we talk about the service API, we have custom resource definitions, which are logical extensions to the Kubernetes API. These make really good sense for Ingress controllers because there's so much stuff that they're capable of doing. And when you have a bunch of annotations, that become problematic for your DevOps folks or your automation specialists who are trying to programmatically handle all this stuff. You're just thrown in a giant string array. It doesn't help anybody. You should be able to programmatically address these as objects. So in this example, we've set up a strip prefix API, who is it? And we can see here in this example that that prefix got stripped off when I made the request, right? Nothing too magical there. Now, it's possible to actually configure using a CRD the entire Ingress route. This is like a full-on baked out replacement for Ingress. And as you can see here, the point is like we're setting up our entry point, we are setting up the route, and we're setting up a redirect for this route. So I'm going to apply this real quick and deploy it. It should only take a second. All right, so that is deployed. And if I look up in the dashboard for this, we can see that the whoami CRD, the web and web secure got deployed. It got deployed with that redirect route, which we set up here on port 80. And let's go ahead and go to that URL real quick and see what happens when we land on it. So we can see here that the 301 redirected us to the secure page. We are on a secure connection. We can see that we got forwarded, the X forwarded proto is here, and we landed at the Git CRD. Again, this solves part of the problem of moving all that configuration out of the annotations, but it's still provider specific. It's not vendor neutral, and it requires a lot of configuration that most application developers, as I mentioned, they don't care about. They shouldn't have to worry about, like things like redirects, TLS, entry points, all that stuff. They shouldn't have to see any of that. So how does service APIs fit in? These are actually going to be here sooner than you think, and it's not going to solve everything. And all the challenges that I've outlined with Ingress so far, it's going to help lay some foundation and groundwork for a more sensible set of resources to help manage Ingress concerns in the future. So I realize I'm at time. I've got about 10 more minutes. Is it all right if I keep going?
I might ask to just try and wrap it up within 5, if that's possible.
Yeah, I think so.
Thanks, Kevin.
Appreciate it. Yep. So over the past few years, even though Ingress has been beta, it's actually been widely used. Like everybody uses it. It's not a mystery. The use cases and the patterns have become pretty evident, and there's a working group now who are focused on abstracting some of this out, defining personas, and kind of laying out how these things should be broken apart. So the initial release is going to focus on introducing 3 new types of resources. We have a gateway class, which is analogous to the current load balancer class of resources. These deal with hooking up the gateways and routes, which I'll talk about more here in a moment. We have a gateway, and in Kubernetes, this resource can't be mapped to anything. It doesn't exist. And here you'll see the cluster operator come into play, and they're going to start handling things like TLS hostname configuration. That's going to be abstracted out from what we see in Ingress today. And then we have route, which closer resembles Ingress, but it's been expanded to include additional matchers and protocols. As mentioned in the last slide, gateway class is there to interface with cloud provider resources such as provisioning ALBs or ELBs. And the gateway class controller is going to permit the configuration of objects through config maps, like a virtual IP pool or CRDs, so that you can validate the schema. Now, typically when a gateway is created, the gateway class is going to provide the bridge to the infrastructure provider. And gateways are going to also provide configuration primitives for listeners on various protocols. So it's going to be able to handle HTTP, UDP, TCP, and accompanying resources such as certificates for HTTPS and TLS and hostname matching configuration. It's also going to be possible to match route resources from the gateway as well as to the gateway via route configuration. So it's going to be bidirectional. You're going to be able to match routes, and you're going to be able to match gateways from the route. So as a final note here, one thing you probably notice is that these resources should be able to be dynamically provisioned. Currently, traffic requires all these ports and certificates to be available at startup. That's kind of like a conflict of interest, and that's something that probably a lot of proxies and ingress controllers are going to have to resolve, which is the ability to dynamically allocate these things in real time. So these resources, the route resource resembles what we know today of Ingress, but we're offloading the TLS configuration, the entry point configuration, all that stuff up to the gateway. In addition, it allows for protocol-specific configurations such as UDP and delegation to other route resources. It's going to be able to match regular expression for both path and host, and you're going to be able to do header matching rules for HTTP routes. Also, all the other things that you might associate with Ingress, such as middleware plugins, rate limiting, whatever, is going to be available as an implementation-specific reference via config map or CRD, like a middleware, like I showed you earlier. So in summary, the Service API is shaping up to provide application developers with resources that will no longer require configuration of those operation concerns, such as certificates, host names, and entry points. And in many cases, application developers only need to associate their route and the route group with the appropriate path name or other matching specifications. Now, the Service API does not provide abstracts for either for other load balancer or proxy concerns, such as those redirects or rewrites, stuff like that, but it's going to expose those in a more manageable approach. It's also not going to make you a ham sandwich, but you probably already knew that. I really couldn't come up with another, what it's not going to do here, because it's going to do a lot. So what's the timeline? Engineers at Traffic are planning on rolling out initial support for these new resources in the next version of Traffic, so 2.4. We're going to start supporting additional route types and dynamic runtime configuration in later releases. And we can expect that Service API is going to be available from the SIG networking group currently at the end of January. And they're going to be releasing it monthly until Q2 of next year. And then they'll reevaluate and probably slow down the release cadence. So just real quick, we're doing a hackathon next week. There's stuff up for grabs. Check it out. I'm going to be doing a blog post pitching some ideas for the hackathon and doing a workshop next week. You can find links to all this stuff in the slide deck. If you have any questions, hit me up on Twitter, not sure if Kevin, or on our community forums. And for those who stuck around and watched me fumble through my demo, I appreciate it. Here's a link to the giveaway. I'll link this in the chat window. And again, thank you all for bearing with me, and I hope I was able to get through in 5 minutes. Appreciate it.
I appreciate that as well, Kevin. Thank you so much. And thank you to all of our speakers tonight, to James and to Alex as well. Really appreciate you sharing your experience with us. All right, that is it for this evening. Thank you so much. We are going to be back again in November, the first Wednesday of November as usual. So have a great evening and see you again next time. Bye.